Morning. I hope that you are doing great. So we want to continue our lesson. We start chapter 2 today and then continue a little bit. If we have extra time, you can work on yourself for the coming exam. Okay, so let us start this new lesson. We want to talk about equations of straight lines. There are two formulas in the book. There are two ways of looking at the equation of a line, which is mentioned in the book. I think both of them are good to know, even though they are completely equivalent. If you learn one of them, in principle, you are independent of learning the other one. But I recommend you to try to learn both ways of dealing with the problem. Okay, so the first thing is that we want to talk about equations of straight lines. So what does this mean? How we can address this question? So every one of you knows about this coordinate system. So assume that you have a coordinate system, x and y. This is the x coordinate and this is the y coordinate. Okay, there are some particular form of lines that writing the equation for them is very simple. And of course, it's very necessary and crucial to know about them. One thing is the horizontal line. Okay, for example, if I draw a horizontal line, say that this is 1, 2, 3. So assume that this point is point with the y coordinate 3 on the y-axis, and then you want to draw a line parallel to the x-axis that passes through that point. And I am asking you, what is an equation for this line? Okay, we want to find an equation for the green line. First of all, we need to understand what is the meaning of finding an equation for a line. So it means that you need to find a relation that specifies the points on that line. So what is the common property of all these points that you see on this line? If you can find that common property and express it as an equation, then that is called an equation for your line. So this is completely generic. If I have a curve like this, when I say what is an equation for this curve, it means that what is the relation between x and y coordinates of the points lying on this curve. If I can find a connection between x and y coordinates of all the points on that curve, that equality, that equation, that relation is called an equation for the graph, for the curve, or for whatever shape you have. So that is the meaning when I ask you find an equation for a shape, for a figure. It means that pick a typical point from that shape and try to use the properties of that shape to establish a relation between x and y coordinates of that typical arbitrary point that you have chosen. As soon as you have that equality is called the equation of the curve or whatever shape you have. This is important to understand when I say an equation, because you know that when I am dealing with a line, it means I am in the realm of geometry. I am dealing with a shape, which is a straight line here. On the other hand, when I ask you to write an equation, I am in the realm of algebra. Okay? And this analytic geometry, this is that we are studying right now, is a connection between geometry and algebra. Okay, so we want to specify each geometric object with an algebraic equation or with numbers. We have already done that with points. If you remember in Math 1C, when I ask you what a point is a geometric concept. Of course, this is a good representation of a point, even though point shouldn't have any dimensions. The dimensions of point is 0 in any direction, yes? So that's an abstract notion in your head, okay? So yeah, but you agree with me that this, for example, this little dot, red dot, is a good representation of a point. So anyway, point is a geometric object. But we learned by setting up a coordinate system, I can associate two numbers with any point. What are numbers? Numbers are in algebra. So I am connecting the notion of a point, which is an abstract geometric shape in my head, to algebra of two numbers. So for example, I would say that if this coordinate is 3 and this one is 2, then I will say that the point A can be represented by two numbers. One of them is 3, the other one is 2. Yes? So the notion of a point can be addressed by two numbers in the plane. Numbers are in algebra, point is a creature in geometry, we are connecting them. Now we want to push this analogy one step further by saying the same thing. After points, you know that in geometry the simplest possible object is a point, but after a point it comes to lines. So the simplest possible geometric objects after a point is a line. So it's a natural question to ask, is there any way to address a line, which is a geometric shape, by my algebra knowledge? So that, because usually working with algebra has a great consequences, so you can just use your algebra knowledge whenever you want to. You can add equations, you can multiply them, you can do a lot of things with equations using your algebra knowledge. If I can express a line with an algebraic equation, and then I can understand the relation between a line and its equation. This is crucial, otherwise that's just memorizing things. If you understand the connection between the equation that you are writing and the geometric object that is described with that equation, then this will bring you a lot of power in mathematics, because whenever you are dealing with a shape, okay, you translate that shape into the language of an equation. You use all your algebra knowledge that you have gained so far to manipulate those equations in a way that you need. And after that, you interpret the final answer geometrically once more. So it means that you actually go from the realm of geometry to the world of algebra, do your calculations in algebra. What you get at the end, you interpret it in geometric way. So it means that you solved your problem in geometry by going to the algebra land and going back to geometry. Okay, so that's the important thing actually we want to learn in this kind of geometry, which is called analytic geometry. Analytic means that I am working with numbers in algebra. Okay, so that's the main point, but it is very crucial to understand because they are not the same thing. This is a line. For example, every one of you know the equation might be, we will immediately write this. Let me write the equation first and then see that what's happening. Okay, so if you understand what does it mean, I want to write an equation which represents this geometric shape. What do? I would say that let me pick a typical point on this line. Any point that you like. This point, let me call it A. There is an x coordinate for the point A, and there is a y coordinate for the same point. And then I want to use the geometry, the geometric properties of this line to establish something, to say something about x and y or their mutual connection. Okay? So I think it's extremely simple for you that you say that what is the relation here? For x values, I cannot say something in particular, yes? Because x can be any, so because you see that by changing these points, these x's are changing. So if I am looking at this point, the x value is this. But if I am looking at this point, then the x value is this. But one thing is clear, it doesn't matter if I am looking at this point or I am looking at this point or any other point, the y coordinates are the same. So if I ask you what is the y coordinate of this point, you can say that this y coordinate is 3. If I change my point to B, still you don't know what is x, but you can be certain about one thing, the y coordinate is again 3. And it doesn't matter which point I am choosing, they share one property. That property is that y is equal to 3 for all of them. And please interrupt me whenever you don't understand anything, because I cannot see your faces in the way that I am recording and everything. So please interrupt me whenever you don't understand something. So if I ask you what is the common property of all the points on this green line, you would say that all of them share this property that their y coordinate is equal to 3. But this is not enough, be careful. You need to make sure that any point with this property also lies on my line. So here I convince myself any point on this line has this property. But is there any other point somewhere else, not on this line, with that property? Here the geometry is so simple that you immediately answer no. Is it possible to find any other point not on the line with this property that the y coordinate is equal to 3? The geometry is so simple that you can say no. If, for example, I choose that point, the y coordinate is bigger than 3. I don't know, if I choose this point, this is less than 3. If I want to have y equals to 3, then I have to be on this line. So I would say that this algebraic equation, do you see? Is this a line? No. Who says that this is a line? Yes. This is not a line. This is an equation. On the other hand, this is a line. But I am saying that this equation represents this straight line. This word represents should be very clear for you. What does it mean? It means that if I have a point on this line, it satisfies this condition. Moreover, any point in the plane having this property for its y coordinate definitely lies on this green line. So this is why I would say that y equals to 3 is an algebraic equation that represents this line, which is a geometric object. Okay? But working with an algebraic equation of this form is simpler than working with geometric shapes, yes? Or hopefully it is. But you need to have a good understanding all the time. You need to be able to translate between these two languages, geometric language and algebraic language, as if you have a dictionary from Swedish, for example, to English. So you should be able, whenever you need, you should be able to jump from this picture, geometric picture, to algebraic picture, or the other way around. So this is crucial to understand. So this, I would say that y equals to 3 is an equation for this line. Is that understandable?
Yes.
Okay, so it's extremely important. But why? You see, I am using this article and, not the. The reason is that if I write another equation for you, 2y equals to 6, If I ask you, are these two equations identical? The answer is no. If you show this to kids, people immediately understand the differences between these two equations, so they are not identical. But are these equations, from algebraic points of view, equivalent? So identical, these are the words that I am using, identical. So the answer is no. Equivalent? Yes. So if someone tells me this is an equation for this, I agree with that one as well, even though I myself prefer to write this because this is a simpler version of that one. They are equivalent. What do I mean by equivalent? It means that whenever this happens, that y is equal to 3, definitely this also happens, because in that case 2 times y is definitely 6, and if this happens, that 2y is equal to 6, I immediately realize that y itself is equal to 3. So if someone says that no, I want to represent this line with this equation, that's also correct. But usually in algebra we have used to simplify equations as much as possible. So my preference is not to stop here, but to stop there, because y equals to 3 cannot be simplified more. So this is why it is not correct to say find the equation for the green line. The equation means that there is a unique equation for the green line, which is not, of course, true. You see here at least two versions of different equations representing the same line. So I have to use an equation for the green line. The green line is just one unique. A line that passes through this point parallel to the x-axis is a unique line, and that is here. Okay, so one thing is, if I give you a horizontal line and I ask you to write an equation for this, what you need to do is to find any point. If you need to find a point on that line whose y coordinate is clear for you. As soon as you get that number as the y coordinate, you write y equals to that number is the equation of that line. Yes? So for example, if I ask you, if I go to Geogebra here, if I ask you what is y, let me just draw it, y equals to 3, you see I get this line, which is a horizontal line passing through 3 here. And then it doesn't matter if I ask Geogebra, for example, to draw 2y equals to 6, you see? You don't see any difference. Let me just clean this one. And let me do it once more. So you see 2y equals to, let me clean it and bring it back. You see 2y equals to 6 is exactly the same line without any changes. Okay? So for example, I don't know, you can write very strange equations. So for example, I can write square root of why this is this. Let me see, how can I type it here. There was something coming up when I was doing this. It's not here now. Anyway, any equation that you can get by solving this, which is y equals to 3, this gives you the same horizontal line. Okay? For example, if I give you another one, y plus 4 equals to 0. This is this equation, yes? Because y plus 4 equals to 0, it means that I don't have any constraints on x. You don't see any x in this equation. Whatever you care is the y value. What is the y value? From this equation you realize that y is equal to minus 4. So it means that I have one constraint, the y values should be minus 4. So immediately you realize that this should be this line which passes through minus 4 but horizontally. Okay? I think you immediately realize what happens to vertical lines. Yes. So if I give you a vertical line, for example, that passes, for example, from 1, 2, 3, 4, 5 here, assuming this is my line. Oops. What happened? I don't know, but let me just do it once more. Okay, so here 1, 2, 3, 4, and 5. Now, if I ask you, can you give me an equation in the world of algebra that represents this purple line, whatever the color is, for me, you would say yes. What you need to do, you need to think in this way. You need to work a little bit, to do some trial and error, to see that can I find a common property for all the points that lie on this line. So what does it mean? It means that you pick a typical point on the line, call it B with X and Y coordinates. You need to use the geometric properties of this line to find a connection between X and Y, or say something about X and Y. It's very clear. What can I say about any one of these coordinates on this vertical line?
That X equals to 5.
X equals to 5. So as simple as that. So I would say that this line, which is a geometric object, can be represented by X equals to 5, or any equation which is equivalent to this equation. For example, I can say 2x minus 10 also works, because in algebra these two are not identical, but they are equivalent. Whenever this happens, this also happens, or whenever this happens, this also happens. But everyone in algebra prefers to work with simpler equations. So very, very simple one. If I have a horizontal line, I know what to do. If I have a vertical line, to write an equation of that, I know what to do. Yes? So hopefully you are, for example, if this is minus 2 and I have this vertical line, what is the best equation for this vertical line? Is x equals to minus 2. Yes? So it is very clear. So for example, if someone writes this equation for you, so let me write this example, even though it's very simple now. Example. I would say determine an equation that passes an equation for the line, and of course I need to express a straight line, because in principle this is also a line, it's a curved line. But because we are always working with a straight line in this chapter, so let me make it short and I say the line. So determine an equation for the line. I'm a little bit, my brain hasn't warmed up yet, but anyway. So determine an equation for the line that passes through the point A with coordinates minus 3 and 5, and so for example part A is parallel to the x-axis, part B is parallel to the y-axis. Yeah, it is very, very simple. So let me write the answer immediately in front. So what's the answer for the first part? Hello, what's the answer? Oh, it seems not very obvious. Do you have any problems? Okay, so let me just repeat it again. So what you need to do, it's better to find a relation between algebra and geometry. So what we do, we try to understand it from geometrical point of view first. For example, I will consider a system of equations, a coordinate system, and then I will try to locate this point. For example, minus 3 and 5, it's minus 1, minus 2, minus 3, 1, 2, 3, 4, and 5. Yes, so this would be this point here for me. So I would say that this is my point here. If you tell me what is this, here is minus 3, and what is this? Here is 5. Okay, so let me write it a little bit here. Yes. Okay, now let us try to solve the first part of the problem. I want to have a line that passes through this point. How many lines are passing through that point? Infinitely many. This is one of them, this is one of them, this is one of them, I don't know, this is one of them. There are infinitely many lines that passes through this point. But in part 1, I am not interested in all of them. I am interested in only one of them, which not only passes through this point, but it is parallel to the x-axis. So it means that I am interested in this line, yes?
Idea.
Yes?
Maybe it's y equals to 5.
Yes, you are right. I am just, parallel to the x-axis, exactly. Parallel to the x-axis, part A of this problem is this line. Yes, and I hope that you immediately realize the equation is y equals to 5 for the same reason. When I ask you find an equation for the line, from geometric picture you try to sketch a graph for yourself to understand the behavior of the line, and then you immediately realize that if I pick a point here, and then any point on this line has this property that its y coordinate is equal to 5. And then yes, you are right. So this is simply the answer. You really don't need to do anything, but you need to have a good geometric imagination. You visualize this problem. You don't need even to bother to draw a very careful graph for that. Just sketch something to understand what's going on. And then you immediately realize that the equation, an equation that can represent this line is y equal to 5. Is that understandable?
Yes.
Okay, and the same thing now, I think hopefully it is clear for the second one. So what's the answer to the second one?
X equals to -3.
Yes, exactly. So because now I am interested in the line that passes through the point. So let me just mention that in this case this is our point, and now I am interested on an equation for this vertical line that passes through this point. But immediately I realize that there is something in common between all these points. I don't know about the y values of these points, they can change, but one thing is clear, the x value of these points is equal to, x value is always equal to -3. So these are the equations, as simple as that. So you need to have this connection between geometry and algebra all the time, okay? So we were able to answer these questions here. This is part A, and that is part B. Okay, but of course, the natural question is that what happens if I do not have any vertical line or horizontal line, if I have just any inclined line, and I'm still interested to find an equation for my line. Okay, that's a little bit more complicated, but because I think it's better not to memorize things, to understand things. So let me draw another coordinate system for you. So first of all, let me try to ask some questions from you. Okay, if I want to find a line, because if I ask you how many lines are there in the plane, you would say infinitely many. If I want to write an equation for one of them, it means that I should find a way to address exactly one of them, because I have infinitely many lines in the plane. This is one line, this is another line, this is another line, this is another line. These are infinitely many lines in the plane. So if I want to address exactly one line from this collection of lines, I need to kill all degrees of freedom. What do I mean by killing all degrees of freedom? You see, I can imagine lines that are shifted left or right, up and down. So you see, I can have a translational degree of freedom. I pick this line, I can move it to the left, I can move it to the right, I can move it up, or I can move it down. So that's a degree of freedom. Okay? Another degree of freedom is rotation. For example, here I can have a line here, but I can rotate it a little bit. Still it's passing through the same point, but this is a new line. I can rotate it a little bit more. You see, I am rotating the lines. So I have another degree of freedom here. If I want to address exactly one line, I shouldn't let my line to have these degrees of freedom. Yes? So a point is good for killing the translational degree of freedom. If I ask you find an equation for the line that passes through this point, then you will forget about this line, for example. This line does not pass through this one. You will forget about this one. So this will kill you translational degree of freedom. This point means that I am not looking at these lines, cross them over, but there are still infinitely many options available. Which one I mean, I need to make this one also unique. Okay? And this one, I give you the angle between that line and the x-axis. For example, I would say that I am talking about a line that passes through this point and intersect the x-axis, for example. I could have chosen y-axis, but the convention is the x-axis. I'm interested in a line that passes through this point and intersects the x-axis with 45 degrees. Okay? Can I draw this line then? No. Because even though this is passing through this, but it intersects with 90 degrees, so I can forget about this. Can I, for example, do this? You would see that this is it's bigger than 45, so I will forget about that. But then, which one? The one, for example, if I can draw it more or less correctly, then this would be a line like this. I want you to understand that this is unique. If I have a line that passes through this point and intersects the x-axis with 45 degrees, there is only one line on this plane with this property that passes through this point and intersects the x-axis with 45 degrees. Is that more or less understandable intuitively from geometrical point of view?
Yeah.
Yeah, okay. So it means that when I give you a point and when I give you the angle of intersection of the line that you are interested in with the x-axis, then there is one single line with those properties. Then it means that from algebraic point of view, these two pieces of information, namely this angle, namely this point, would be enough for me to answer the question of my line. Okay, so let me just try to take this one and try to solve it together as a case. For example, let me, I don't know, choose one point here, 1, 2, 3, 4, 5, and say, for example, 3. So this is my point A with coordinates 5 and 3. So let me just make it clear for you here. So this point here is 5, and then here I am assuming that this point has these coordinates. Now I want to ask you the same question. Write an equation for a line, for the line that passes through the point A and intersects the x-axis with 45 degrees. For example, you immediately see that this line is not acceptable because this angle is very small. It's smaller than 45. So, but let me just try. I cannot draw exactly 45 here, but let me try to do my best. Okay, so for example, I would be interested in this line. Yes? Hopefully you agree with me, this is a good approximation of that line.
Yes.
Yes. So let me make it a little bit better. Oops. Yeah. This feature sometimes works, sometimes doesn't work, but let me do it once more. Yeah. So, yeah, good. Yeah, more or less good. Yes. I can fix it probably a little bit better by moving it up. Can I? Yeah, better. Okay. So now I want to find an equation for this pink line. Okay, and let me continue this a little bit because I need to work from that side as well. Okay, so let me continue this. Okay, good. So this angle is 45, and I know the coordinates of my point. One x coordinate is 5, the other one is 3. I want to find an equation for this line. First of all, that simple idea will not work here, yes? Because if I choose a point here and I choose another point, you immediately realize the x-coordinate was this, and then suddenly the x-coordinate is here, so the x-coordinates are different, and the y-coordinates are also different. So it is clear that this is not that simple as before, that either the x-coordinate is the same or the y-coordinate is the same. So it means that I need to pick a random point, a typical point, it's better to say. I will pick a point here, let me call it M, and I would say that the coordinates are x and y. And I want to find a relation between these two so that it guarantees this point to be on this pink line. So how can I do that? Do you have any idea? How can I find, by this information that you see on the picture, I have 3 pieces of information, the x-coordinates of my point, the y-coordinates of my point, and the angle that this line makes with the x-axis, which is given in this problem to be 45 degrees. Using these 3 pieces of information, can I find a connection? And of course, geometric property of a straight line, that we know it when we grow up. We already know what is a straight line. Everyone have an intuition about that. Using that geometric property, how can I connect? How can I find a relation between y and x? And I think, as you are thinking,
you have 2 points, right?
I have 1 point actually, which the numbers are given. The other point is not given. I want to find a relation between them. And I don't want to use your knowledge, because your knowledge tells you how to calculate this. But I want to come to that knowledge. That knowledge was actually somehow instructive knowledge. I give you some instructions, you use them, you find them. But I want you to understand why I can prescribe that instruction for you.
I'm thinking that there's a ratio between 5 and 3, and the ratio should be same between x and y.
Okay, so somehow it's correct. So this means that this is the property of the straight line. Yes. So what can I do here? So if I want to do it, let me do it in this way. So for example, if I ask you this point, let me just draw a horizontal red line here and a vertical red line here. And let me ask you once more, what would be this angle now? Of course, I have already given you this angle, but can I immediately answer this angle as well?
Yes.
What is that?
Since it's a straight line.
Yes. So you see, I am using geometric property of a straight line. Do you remember what was that theorem that we had in geometry? First of all, what is this angle, everyone? It's 45. But what was the theorem? The theorem, if you remember, was two parallel lines and a transversal. Yes? If I have two parallel lines and a transversal, then we learn that this angle and that angle should be equal using geometry. In the world of geometry, I am discovering properties of a shape, yes? So the reason that this is 45 degrees is because of a geometric problem. It's not algebra yet. Everyone agrees that using this theorem, I can immediately realize that this is also 45 degrees. Yes?
Yes.
And now you know that if I ask you what is the type of this triangle, you would say that this is a right angle triangle. And I know that this angle is 45. So what is the other angle here?
45.
It's also 45, yes? So you see, I am not using algebra at all. I am just using geometry. So this is 45 degrees. And then, again, geometry. If I have a triangle in which two angles have the same size, I can immediately conclude that this triangle is an isosceles triangle, yes? Meaning that if I call this point, let me call this point N, it means that MN is equal to AN. Everyone agrees? Okay?
Oh.
Is that clear for everyone? MN is equal to AN. Good. And now if I ask you, what can I write for MN using these pieces of information that you see on the picture? I hope that everyone agrees with me that this, if I ask you what is this length, can you write something for this length using the information here? Now I am going to the world of algebra, okay? So this if I say where this equality is coming from, this equality is not coming from algebraic arguments. This equality between these two line segments is coming from geometric arguments. But now I want to enter the world of algebra. Okay? So what can I write instead of MN? This purple length that you see here. Can you write something for it? So let me just draw this line for you. If I ask you what is the length from here to here, what's your answer?
Plus 3.
No, we don't know. Because from here to here is the y coordinate of this m. Do you agree? If I ask you what is from here to here, you can immediately answer. What is this length?
Yeah, but that's why I specified the line MN and then plus 3 because it's...
Okay, now what I'm asking is that from here to here, what is this red line that I am drawing? What is the length of this red line?
Oh yeah, we can't answer that.
We can't answer that, but we can write something for it. What is that?
The y.
Yeah, that is y, exactly y of m. So I am asking that. I know. Of course, if you ask me what is the exact value of y, I don't know because it depends where this point is lying. If I go higher, of course, y is greater. But if I ask you what is from here to here in terms of these numbers, I hope that you agree with me. This length, even though it is not determined yet, but this length is y. And if I ask you what is this length, you can answer. What is this length?
3.
It is 3. But I am interested in MN. So can you write something for MN now using this picture?
Y minus 3.
Exactly. So hopefully everyone agrees with me now that instead of this I can write y minus 3. Agree? And now can you tell me what can I write similarly for an? So let me make it clear. So on this picture here, this is y minus 3. If you don't understand that, please ask me again. From here, I am claiming that this length is y minus 3. Why? Because I see that this length from here to here is this big length. If I ask you what is this, you would say it's this y coordinate, minus this length. If I ask you what is this is equal to this is equal to this, and that is 3. So everyone hopefully agrees that this length is y minus 3. But now I ask you the same question for an. Can you write something for an?
Maybe it's x minus
X minus?
X minus 5.
X minus 5, yes. Why? Because I ask you, if I ask you what is this length from here to here, you would say this is this point with x coordinate x, so it means that this big length is x. If I ask you what is this length, it's clear, it's 5. And now if I ask you what is this length, it is x minus 5. But there is no difference between this length and an. So an is also x minus 5. Yes? So this becomes x minus 5. Do you remember what was my goal? My goal was to find a relation between x and y. I found it. This is my relation. And that is an equation. We are done. So what I am doing is that, of course, in algebra, nobody leaves this like this. People try to simplify it algebraically, meaning that they move 3 to the other side, and then they would write x minus 2. And this, they will write this is an equation for this line. So you see, this is a very simple example. And you see, I am not using any formulas at all, because all those formulas that you learned in Math 1C, still, don't be afraid, this shouldn't be so hard, but I don't want you to memorize mathematics without any soul, you know. But I'm just telling you that I want you to see these connections. Of course, I myself never, ever solve this problem using these kinds of arguments all the time. But I will learn this once, and if I need, I can replicate it for the students, for someone that I want to describe it. But then, after that, when I learn that, I formalize this, because I see that I am doing it over and over again, and it might be very boring if I want to do this over and over again. So I will summarize it in a compact form so that I can apply it for similar cases over and over again. But what I am saying is that if someone asks you how we come up with this equation, we actually came up to this equation with geometrical arguments. You see, what I used was this theorem from geometry, parallel and transverse lines. We talked about, I don't know, right angle triangles, and I realized that if two angles are the same, this can be isosceles and whatever. Okay, and then I used all those arguments and I wrote an equality. But this equality is not in algebra. It is in geometry, because it is telling you that two line segments have the same lengths. Yes? This is a geometry. But then, little by little, I started to translate this into the language of algebra. And then I found this equation. But if I ask you, is this a line? No, this is not a line. This is an equation. There is nothing like a line in this equation except these two parallel lines here, okay? But this equation represents this pink line. What does it mean? It means that any point on that line, for example, this, has this relation between x and y coordinates of all the points on this line. It doesn't matter which point you are looking. If you go and locate this point, probably we can test this idea. Let us go to Geogebra, for example, here. Let us get rid of them. And then let me type this equation that we got here. Y is equal to x minus 2, yes, and that is this equation. And do you remember what was the point? The point was 5 and 3, so let me just locate that point for you as well. So 5 is equal to 5 and 3. And then what happens, you see this point appears here. I can make it a little bit bigger so that you can see it. Make it a little bit bigger. Okay, now it is more visible. So this is the point 5 and 3, and that is my line. So now let me go and pick another point. You see, randomly I just select this point tool here, and let me just, for example, just locate this point. You see what's happening? It is 8 and 6. Again, you see the y coordinate is x minus 2. So it means that the y value is x minus 2. When I pick even a random point, you see that relation works. Okay, so I don't know how GeoGebra is precise. Let me try to choose this point. You see again, x coordinate minus 2 is the y coordinate. It doesn't matter which point I choose. This line, you see, this is negative, minus 3 times this. If I subtract 2 from it, it becomes negative 5. So it doesn't matter which point you are choosing on this line. The y coordinate of that point is equal to its x coordinate minus 2. Okay? And the other way around, if you choose any random point, so for example, don't look at this line now. If I choose a point whose x coordinate is, whose y coordinate is x coordinate minus 2, for example, let me choose a point here. So let me write it as b equals to, for example, this is b, I don't know, let me call it g, equals to, just give me a point, for example, let me write minus 9, minus 9, and then what? Minus 11. Yes? So this is minus 9 and minus 11. The y coordinate is minus 11, the x coordinate is minus 9. If I subtract 2 from it, it becomes minus 11. So where is it? I need to go and find it. Where is g? Where is g? G is here. So let me open the label. You see this is point G. Okay? Now let me go back and make the line clear. You see the line is passing through that point. So these things are extremely important to understand. Okay? So if you have any point with this relation among the x and y coordinates, definitely that point would be a point on your line, and vice versa. Any point that you pick here, it doesn't matter how randomly you do that, if you check all these numbers, if you see, you will see that the y coordinate of each one of these points is 2 units less than the x coordinate. So this is extremely important to understand. Okay? Any questions so far?
No.
Good. Good. So let us go back here. Of course, this was also a particular form that we were able to find this. But now let us go and finalize the problem. Can I solve this problem algebraically, not for this angle, for any angle, not for these numbers, for any numbers? This is the power of algebra. Okay? So what does it mean? It means that I want to look at the same problem, but in a generic way. What do I mean? So let me change the colors as before. So here I have this, and then for example I have this. What do I mean by algebraically? That means, let me just draw the same idea. For example, I have this line, yes, and then instead of A with numbers 5 and 3, let me assume that A, so let me just choose the colors exactly as before. So here I have A, instead of 5 and 3, let me give you two numbers, x0 and y0. You can choose A, B, or what, this is the common notation that I am using, x naught and y naught. Instead of 5 and 3, I have a typical number. And instead of giving you this angle to be 45, let me give you this angle to be theta. So if I ask you, you need to understand, if I ask you, are these numbers given? No, of course, nobody knows what is x naught, what is y naught, what is theta. But assume that these are given to you and you want to do the same idea to solve this problem. Okay, it might be a little bit harder in this case, but hopefully you can manage to do that. So how can we do this here in this particular way? Again, you shouldn't lose the logic. The logic is to pick a typical point here, for example M, and call it x and y, and try to use this given informations to find a connection between x and y. Okay? So how can I do that? This is a little bit harder, but it's manageable, and I think it's enjoyable to understand. Don't worry about this. Try just to enjoy what you are learning. After that, I will formalize. If you don't like these kind of arguments, you can just throw everything away. If you just want to memorize, if that's okay with you to memorize, and then you can solve the problem so you can succeed in exam. But if you want to have a better, deeper understanding, this is the way that you need to look at the problem. So can you help me to do the same thing before, if you are interested? So how can I do that? I want to find a relation between x and y. This time I'm assuming x naught, y naught, and theta are given to you. You see, it is very similar to the idea of that part. So I even try to keep the colors as the same. Any ideas?
So we could start off by drawing a line from the points like down to the x-axis.
Yes, so let us do that. So what the point, so you are saying that, let me just follow exactly what you are saying as far as it is correct. Yes, it is needed. So you are saying that I will do, and then I would probably write x naught here, yes?
Yeah.
And then I will do the same here and write y naught. Okay, yes. Do I have any problems with x naught and y naught? No, I am assuming that they are given. Okay, then what?
So do the same thing for m with
Exactly.
x and
Okay,
y.
so let me just do this one here as well. So for example, like that, this would be a right angle triangle. If I ask you what is this angle, can you answer now?
It's theta, right?
Yeah, it is exactly theta. Okay, but this time the geometry is a little bit more complicated. 45 degrees was a very special case, so immediately I was able to write mn is equal to an. Okay, but here the problem is a little bit harder because I don't know if they are equal. Of course, in general they are not. In this picture it is not, yes? Okay, but let me denote the same thing here, an. Okay, but can you still tell me what is mn? Of course, mn and an, I cannot write equality between them because in general they are not equal. But can you tell me what can at least I write for mn? Something similar I did here for mn. What was the idea? So this is important. When you learn mathematics, don't give up with the ideas unless they are useless. What was...
Could you write it as mn is equal to y minus xo, like the green line?
No, not the other way around. Why xo? Yo.
Well, I mean, if you draw like a line from mn down.
Yes. So this is what?
And then you just subtract, you see the line next to the xo, the green one. You subtract it, then you have mn.
Okay, but what is this length? Yes, what is this? What is the length from here to here? So let me ask you again. What is the length?
It's y.
From here to here is y, exactly. What is from here to here?
It's xo. Oh, no. It's yo.
It's yo. So that was your mistake.
Okay.
That is yo. Everybody agrees? It's y node. Okay, it's not o. It's simple 0 or something. It's called node. Okay, so y node, y minus y node is mn. Hopefully everybody agrees with me. Y minus y node. Very small little dot here to distinguish it from y. Is that understandable for everyone, what I have written here? Do you agree with me?
Yes.
Okay. Now can you tell me what can I write for an?
X minus X node.
Yes, x minus x node. If you have a little bit of doubt about this, let me justify it here. So if I ask you what is from here to here, this is exactly the x coordinate of this, so this is x. But from here to here is x node, and I am little in this small piece. Why? Because this is equal to that one. And this is exactly x minus x node. Yes? But in the previous case, it was very simple for me because it was 45 degrees and I immediately realized mn should be equal to an. Okay, but here I cannot do that. Do you have any suggestions? How can I continue now? Try to concentrate on this little triangle here. You know something about this side, mn. You know something about this side, an. Yes?
Well, they are similar triangles.
Yes, that is one idea. Yes, that's one idea, and it's a good idea, but I want to do it in a different way. If I have
tangent.
Exactly. Tangent of a theta is the opposite side. Opposite side means mn divided by an. Yes? So what is mn now? Mn, you know something about it. It's y minus y node. And about an, you know something about it. It's x minus x node. Okay? Do I know tangent of theta or not? Yes, I do, because I told you that theta is given. Pretend theta is given. If the theta is not given to me, they cannot expect me to be able to write an equation for the line because I don't have any line in the first place. If I want to write an equation for a line, the line should be clear for me, so then I can try to find an equation for it. So it means that if the line is given to me, they have chosen to give me these pieces of information. They have given me x node, y node, and the angle theta, exactly as I had here. Then I was able to solve. So if I ask you, is tangent of theta is a known number to me, you would say yes, because you told me theta is given, and then I can put this in the calculator or any way that I know, calculate tangent of theta. So the tangent of theta is a known number to me if theta is known to me. Is that clear?
Yes.
Okay, and then what happens? And I am done. I don't need to do anything more. So this is my equation. It seems a little bit strange, but this is what I wanted. So I want you to understand that you are done. It's very important to understand the problem is finalized. Even though it is not algebraically finalized, I can play around with algebra, with equations, to make it a little bit more beautiful. Even though this is also very beautiful for me. Anyway, why this is done? Don't lose the logic. The logic was to find a relation between x and y, including, of course, these given pieces of information. I got it. What do I mean by relation? I mean an equality in which you see y and x. Whatever you see there should be the given pieces of information. Let us look at this, what I got. I have a relation because I have equality, good. I see y and x in that relation, good. Whatever I see there except y and x are given pieces of information. So I am done. This is the equation of that line. Is that understandable?
Yeah, I have a question. So, when you do this, you get like the if you have like a straight line, it's y equals kx plus m. You get the k value.
Yes.
Or you get the m value.
Yes. I will come to this.
Well, I know how you get it, but I mean, it's how is it finished?
Yes, I haven't finished it yet, but I want to I want you to understand that what I got is completely correct, and I can stop here and say that this is your equation that you were looking for. I want you to understand these things. Why this is an equation that I can stop here? Because I see equality. In that equality that I see, y and x are involved as I expected. Any other thing that is involved in this equation, one of them is theta, the other one is x naught, the other one is y naught, but I assume that these are given. So it means that this equation is a relation between y and x. That's it. Now, this is a little bit a strange form. Probably you haven't something so, because I know that in high school people, whenever they see trigonometry, they freak out, but there is nothing to, because this is just a number. Yes, theta is an angle. You put that angle in your calculator, press this tangent bottom, it gives you a number. That number is just number of tangent of theta, and y naught and theta naught are this. So for example, to make these things understandable for you, so let me do this problem that we know the answer to using this formula that we got here. Do you expect that this formula should give you the same answer? Just say yes or no. Yes, good. So this should give you the same answer. Let us check. Okay, what should I put here? Can you tell me? For this equation, let me write it here. I should write tangent. Can you tell me which angle? For this problem, 45. So you just write tangent 45 degrees is equal to, I have a fraction. Do I need to put something for y and x? No, these are typical variables. But what can I write for y naught? Can you tell me? What is y naught?
You can write 3.
3, yes, because y naught is 3, and what is x naught? 5. And I don't know if you have your calculators available. If you don't trust me, you can calculate this number, but if you trust me, I can tell you that this number is 1. You can test it with your calculator, and then it becomes 1 equals to y minus 3 over x minus 5. But now tell me, this fraction is supposed to be equal to 1. What can I conclude?
That they're equal to each other.
Yes, so y minus 3 should be equal to x minus 5. And let me move minus 3 to the other side. It becomes minus 5 plus 3, and then it becomes y is equal to x minus 2. End of the story. So you see, this formula is actually working very nice. Even though it's a little bit of a strange formula, but this is very nice. Okay, but now this is something that I don't know, for some reason in high school studies they don't talk about it at all. But this is what we call the slope. Okay, if someone asks you what is the slope of a line, what is the geometric meaning, there are of course two meanings for the slope. One meaning is coming from geometry, and that is the angle that your line makes with the positive direction of the x-axis. I'm telling you with the positive direction because if you consider this side, then this angle would be this. I don't mean this. So here, if I would say let me write this with red, let tangent of theta, let us call tangent of theta, let us name tangent of theta, it's better. Tangent of theta by k. Okay, then this equation gives you k is equal to y minus y node divided by x minus x node. Okay, and let me go to the next page. There are not enough space here. So what I do, k is equal to y minus y node divided by x minus x node. So first of all, I hope that this formula is familiar for you. Do you remember? You learned this as the formula expressing the slope. Yes, do you remember the delta y divided by delta x? The difference between y values divided by difference of x values. But now let me multiply both sides by x minus x. What happens? This becomes k times x minus x node. On the right hand side I also multiply it by this. But now you remember this one and that one are cancelled, so what I get is k times x minus x node is equal to y minus y node. And then people write it in this way. Y minus y node, they write it on left because we usually write y on the left and then write k x minus x node on the right. This is an equation for the line. This is the same equation algebraically. This equation is this equation exactly by changing the name of tangent to k, which makes it easier to see. And then I simplify this algebraically. So if I ask you, and this number k is known as the slope. So k equals to tangent of theta is called the slope in American books, or gradient in British ones, of the straight line.
The important question is, what do you call it?
I call it a slope. I prefer American ones always. Yeah.
America.
So of the straight line. Okay, so it's
Does
very.
it say Olo?
Pardon? This is not
Does it
Olo.
say Olo?
Yeah, it's my curly S. Yes.
No, we can just keep it as Olo.
Yeah, we can call it Olo if you want. Yes. Anyway, did you understand what's going on? Of course, you can completely ignore this session if you don't like this kind of discussions, but then you have to memorize this formula, where this formula is coming from. Okay, so if first, there are many important things that you learned here. So first you learn that what is the geometric meaning of the slope. So if someone asks you, can you give me a geometric meaning of the slope, you would say now yes. How? If I give you a protractor, if I give you this line and I ask you, can use this protractor Assume that you don't have any ruler available, and your paper is not this grid paper, but you have a precise protractor that you can measure the angles with. Using that protractor, can you find, and of course a calculator in your hand, can you find the slope? Can you find the slope of the given line? Can you find it? What you have to do? You would say, yes, I will go and use protractor to measure this angle that my line makes with the positive direction of the x-axis. I can use protractor to measure that angle. Then I use my calculator to calculate the tangent of that angle. Whatever that number is the slope of the slope of the line. Now let me change my measuring tools. Now this time I give you a ruler instead of a protractor, and I ask you the same question. Can you find the slope of your line using the ruler? Then what you do? Can you tell me? So let me just write these things here as you're thinking. So if I give you the angle, yes, if I give you this angle using protractor, then I can ask you find the slope. You just calculate tangent. This is using protractor. Now I am asking you the same question, but I am giving you a ruler. Okay? So I am giving you a ruler this time, and I am asking you the same question. So how do you calculate k in this case? There are two formulas for k. You see, one of them is this tangent. The other one was this one. Because if this tangent is k, then k is equal to the difference of two y values over two x values. So what you can do using your ruler.
Did we answer?
Yes, why not?
Oh, yeah. So you use the ruler you choose 2 points, you measure the x and y values on them, and then you put it in the fraction.
In the fraction, yeah, exactly. So you just choose any 2 points that you like, and according to these properties that you see here, it doesn't matter which points you choose. So you can just draw horizontal and vertical lines using your ruler, and what you need to measure is this length and that length, and then divide them together. So this length usually is called delta y, and this length is usually called delta x. This means delta in mathematics usually represents the change in a variable. This means the change in y variable. This means the change in x variable. So the change in x variable, the change in y variable, and then what you do, you divide delta y, delta x. So if you have a ruler available to calculate the length, to calculate the slope, you can do it in that way. If you just have a protractor, you don't have any length measuring device, so then you can use this formula to calculate the slope. But both of them are very important, especially this one when you go to higher mathematics. Okay, so you need to know this interpretation of a slope. You need to know this old interpretation of a slope that you probably know from Math 1C, but this is completely new. And I told you that this is not for some reason included in the book at all. I want you to understand that. And the other thing that you are interested is writing to an equation. This formula is also given in the formula sheet, but you need to know how to use that. So I would say that an equation, so let me write this as a remark. So this is what you need to learn if you want to solve problems, yes? Okay, I recommend you to memorize that after understanding it. So an equation for the line, again a straight line, an equation for the line with the slope k that passes that passes, through the point, I don't know, you can call it whatever, let us not call it anything, x node and y node, is y minus y node is equal to k times x minus x node. Okay, so this is the formula. In the book it is called a 1-point formula. Let me see if I am right. This, yes, it is written 1.4 or 1 point, not formula, form. Of course, this is not only enough to give you 1 point. This is enough. So if you want to write it, you not only need 1 point, you also need the slope. Okay, let me give you immediately an example for this, and then I will try to change the form into more familiar form, and that is called the K form, which probably you are more familiar with it. But I myself always prefer to use this, and I recommend you to use this. Start learning how to use that one as well. So I would say that example. So here, write. Now let me write determine. Determine. You see an equation for the straight line that passes through the point, say -2 and -3, with the slope -4. So this is a typical problem. It's a very simple problem, but very important one. So if I want you to write an equation for the straight line for me, for any straight line, I need to provide you with two pieces of information. I need to give you a point on the line. I should also give you the slope of your line. This is the standard way of asking to write an equation. Harder problems are those problems that these two pieces of information are not given to you directly. You need to work on it to extract these pieces of information from the problem. As soon as you have them, you have the formula, replace them, and then you are done. So simple problems are that everything is ready-made for you. You just you put them in the formula. Harder problems are those problems that one or both of these informations are not given to you directly. You need to use your math knowledge, everything that you have learned so far, to extract these pieces of information. But the strategy is clear. As soon as you see this starting sentence up to here, determine an equation for the straight line, blah, 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 blah. You need to make your brain conditional in this way. What you need to look for is to find a point on the line. 1 point is enough, and you need to find the slope of the line. You see, you shouldn't get confused. Yes, please.
What does slope -4 mean in this case?
Yeah, I will come to that. Yes, that's a very good question.
Okay.
Yeah.
Okay.
Yeah, so let me now use the formula to answer this question. So I would say I have my formula, even though this is not very familiar formula for you. You are used to the other form, which is called the K form, and I will come to that. But let us use this formula. But you need to know, this is playing the role of K. This coordinate, the x1, is playing the role of x node, and this one is playing the role of y node, yes? What you need to do is just replace them. So it becomes y minus 3 is equal to minus 4 x minus 2. Be careful about these minus signs. I intentionally wrote them all with negative signs to make sure that you are not confused. So I took y naught and replace it by minus 3. There is a minus in the formula itself, so I will have two minus signs. K is minus 4, and then there's a minus sign in the formula, and there is a minus sign for x naught. So that is what but you are not allowed to leave it like this, even though technically it is complete, but we have to simplify that. So this becomes plus 3, and then it becomes minus 4. X minus 2 is positive 2. Then it becomes x plus 3 is equal to minus 4x minus 8. I'm multiplying this, and I move 3 to the right. And I make it negative, and finally I write the answer here. So the answer is y equals to minus 4x minus 11. This is the equation of this line. Okay, so now you see that this slope is negative. So what is the meaning of a negative slope? Of course, if I ask you what is the meaning of a negative slope using trigonometry, it is possible, but it is not at the level of your math lesson. You need to go to Math 3C. In Math 3C, we will learn that the tangent of an angle which is greater than 90 degrees and less than 180 degrees is negative. So it means that when I see a negative slope, it means that the angle should be between 90 degrees and 180 degrees. So if this angle is smaller than 90, here is the 90. If I want to make the angle bigger than 90, it should be something like this. So if the slope is negative, it means that my line is directed in this direction, yes, something like that. But of course, this needs a little bit trigonometric knowledge that you don't have it right now, but you can use the other idea, ruler way, to see what is the meaning of the slope, negative slope, yes? So when you have the slope negative, it means that these two numbers should have different signs. If both of them are positive, when I divide them, it should be positive. If both of them are negative, when I divide them, it becomes positive again. So when you say that k is negative, it means one of them is positive, the other one is negative. If I decide to move to the right, delta x is positive, because delta x means the final value minus the initial value. So let us decide to go to the right hand side all the time. So it means that if delta y is negative, k is negative. If delta y is positive, k is positive. So it is clear. You see here, I am going to the right, delta x is positive, but the y value also increases, goes higher. By going, you see, I am going from this initial point to that final point in 2 steps, to the right, up. You see, delta x is positive, delta y is positive. When I divide them, it becomes a positive. But let me consider this line here. Let me just draw it with a different color here. So here, let us choose these 2 points, the initial point, the final point. Okay, so if I go to the right, I choose to go to the right all the time because this will guarantee that delta x is positive. But if I ask you what is delta y is negative because the final point is lower than the initial point. So the delta y value is negative. And then again, you understand that when you divide, the k value becomes negative. So it is clear that when I have these kinds of lines, the slope is negative. These kinds of lines, the slope is positive. This kind of lines, slope is 0. These kind of lines doesn't have any slope at all. Okay? So there is no slope for these two. Why? Because if I take 2 points on a vertical line, If I ask you what is delta y, you would say delta y is this length between these two. But if I ask you what is the difference between the x coordinates, it's nothing. So delta x is 0. But the denominator cannot be equal to 0. If it is not defined. Okay? So that's a good question. So let me just finalize this as a remark here. If you have any questions, please let me know. So let me just write this. Just draw a system of equations like this. And then I would say that this line has k value negative. This horizontal line, k value 0. This kind of line, k value positive. And this value, let me change the color not to get confused. So this kind of lines, vertical lines, k value undefined. So you need to understand this one as well. Any questions? Okay, now let me finalize everything so that the lesson is finalized here. So if you go back here, now I want to put this in more familiar form, but I told you I want you to learn to work with this formula as well. So here what we can do, we can say that this equation, algebraically I can simplify it a bit. So it becomes y minus y node. I multiply k inside. It becomes kx minus kx node. And I move y node to the right. So it becomes kx plus y node minus kx node. And let me put this in a pair of brackets, yes? If I ask you what is this, this is a given number, because do you remember I told you that y node and x node and y node and k are given to you. So it means that if they are really given, what you face here is just a number. You put those numbers here, you calculate them, you get a number, 5, I don't know, 7 or whatever. And then this in the book, we can call it m. That's a number, m. And then what you see is the familiar form of the equation of the line. Okay? So it doesn't matter how you want to solve this problem, you can use this one. If you see this, it means that you are facing a line which is not vertical, of course. But that is also good. Let me solve this problem using this formula. So I want to solve this problem. An equation for the straight line that passes through this point with the slope minus 4. What you do, if you want to use this old friend of you, so what you do, you just say that, okay, I would write y is equal, instead of k, the problem has given it to be minus 4, so I put it there, but I don't know m yet. Okay? And then what you say is that there is another extra piece of information given to you, that your line is supposed to pass through this point. So what does it mean? It means that the coordinates of the point should satisfy the equation of the line. That is the meaning of equation. I described it a lot for you today. So this means that, so I forgot, it was minus 2 and minus 3. So it means that if instead of y I put minus 3 and instead of x I put minus 2, this should hold. But then this becomes minus 3 is equal to 8 is m. I move 8 to the left, it becomes minus 3 minus 8 is equal to m. And this means that m is minus 11. But this is not the answer. The answer is this. You go back and replace m with what you got. So it becomes y is equal to minus 4x minus 11. And that's exactly the equation. That's exactly the equation that you got here. You see, that's exactly this one. I want you to practice on this way, even though it might seem a little bit lengthier, but I want you to understand this one as well. Okay? So finally, we were able to have, this is called the K form. In the book, this is called the K form. the K form. Okay. So we learned about two ways of writing an equation of a line. One is called the 1-point form, the other one is called the K form. And then of course I think I will stop here. I have been talking a lot, but it's a little bit more to it. I want to solve a little bit harder problems for you, and I will do it tomorrow. Okay? So what you need to learn is probably from this, what you need to learn for the exam is for just this one. Even though I insist that you also learn this method. But anyway, it's not something very strange. So from all this long lecture, you just need to, of course, to know about these vertical and horizontal lines, how to write the equation for them. And then you can just ignore them if you are not that interested in learning where these things are coming from. But I just want to motivate you that how you can find these rules. This tells you that how I go from geometrical argument to algebraic argument and vice versa. You need to have if you want to have a good understanding, you need to feel this connection between algebra and geometry.
Which was the 1.1?
What 1.1? What do you mean?
We talked about the K form and the 1-point form. Which was the 1-point form?
This one, yes, this one. Here.
And you prefer to use the 1-point form, but we can use whichever we like.
Yes. Yeah.
Just have a question, like, are we going to have these questions where we have a protector or the ruler to find?
No, because because this is not given in the book for some reason. In Math 3C, they somehow assume that you should know it. But I think it's better. This is also something that I want you to know. There are two. Forget about protractors. This is the way that these are the stories that I was cooking up so that you can understand what I mean. But there are two interpretations for the slope. One interpretation is as the usual, the difference between y's divided by the difference between x's of two randomly chosen points on the line. Another interpretation is that you can find the angle between your line and the positive x-axis and calculate the tangent. So that's also important to know. Okay? As far as you understand this connection, you are on the safe side with that. Any other questions?
When are we getting the answer sheets?
Answer sheets?
I think you said you were gonna talk to Thomas about getting us.
Solution manual, you mean?
Oh, yeah, exactly.
Okay, I will write an email. I forgot. I will write an email right now. Okay. And hopefully, when he answered back, I will come back to you guys.
Okay.
Okay, so if you don't have any questions, of course the videos are more high qualities. They are 4K videos when I am doing from home, so it takes a lot of time to be processed by YouTube and everything, but it would be ready in one day. And then of course, as usual, when I am doing something electronically, I will put the links for these notes. If you need the notes, you will find them below the videos on YouTube. Okay. If you don't have any questions, so let me stop this